preferential recognition of Amadori-HSA by circulating antibodies in diabetes with or without nephropathy, impact on protein glycation in the disease progression. Diabetes mellitus is a group of metabolic disease characterized by hyperglycemia resulting from defects in insulin secretion, insulin action, or both. The chronic hyperglycemia of diabetes is associated with long-term damage, dysfunction, and failure of various organs, especially the eyes, kidney, nerves, heart, and the blood vessels. Diabetic nephropathy is a worldwide public health problem and extremely common complication in diabetes mellitus. More than 1/3 of the patients with type 1 diabetes and up to 25% of all with the type 2 diabetes are profoundly contributing to patients' morbidity and mortality. Hyperglycemia is the main cause of diabetes and its associated complications, and it is responsible for the diabetic nephropathy through the oxidative stress, renal polyol formation, nitrogen activation protein kinase C, and the accumulation of early and advanced glycosylation and product in tissues and organs as well. Diabetes is a huge and growing problem, and the cost of society are high and escalating, and in 2016 it is in the world 382 millions, and it will be increases by 2035 by 592 millions in all over the world. Diabetes is associated with serious secondary complications like nephropathy, diabetic retinopathy, strokes, cardiovascular diseases, and the diabetic neuropathy. These are the main diabetic secondary complications of diabetes. And in diabetes, the 4 pathways may be accelerated like polyol pathways, hexamines pathways, protein kinase C pathways, and AGEs pathways. And my work is on non-enzymatic glycation pathway, AGEs pathway. Non-enzymatic glycation is basically a process in which glucose is chemically bound to the amino group of protein without the help of any enzyme. It is a classical covalent reaction in which by means of N-glycoside bonding, the sugar-protein complex is formed, and through the various chemical reactions, this is first described by Maillard. That's why it is also called the Maillard reaction and browning of protein. Basically, in this reaction, glucose molecule is attached to the free amino group of protein and forms Schiff base. After the formation of this Schiff base, this is rearranged into the Amadori product, and various through the intermediate glycosylation product. This Amadori product is formed advanced glycosylation end product. The advanced Amadori product is early glycated product, and the advanced glycosylation product is AGEs, and both are involved in the diabetes and its related complications. But the research is now going on. Various researches has been done on AGEs, but very few is on Amadori product. So my work is on Amadori product, the role of Amadori product in diabetes, diabetic nephropathy. This is our hypothesis that when HSAs react with glucose through the non-enzymatic glycation, Amadori-HSA is formed. And the HSA is structurally damaged, and its function may be impaired. And after the Amadori formation, the immune cells recognize it as a foreign molecules and induce antibodies against it. So these autoantibodies against Amadori-HSA will cause the secondary complications in our body. So to detect the autoantibodies against Amadori-HSA means early glycated product, our aims are to study the effect of non-enzymatic glycation on HSA with different concentration of glucose, to authenticate the Amadori production in the glycated samples by NBTSA, or to study the role of glucose-modified HSA in diabetic nephropathy, or detection of autoantibodies against Amadori-HSA in the sera of diabetic patients with or without nephropathy. So we designed the study. This whole study is conducted at Rajiv Gandhi Center for Diabetes and Endocrinology, JNU Medical College, Aligarh Muslim University, and ethically approved by Bioethical Committee. The diagnosis criteria of the patients is based on the American Diabetes Association 2012 for the classification and diagnosis of type 2 diabetes and the diabetic nephropathy. The work is designed by, in this study, we included 150 patients, and they are divided into 3 groups. Group 1 is healthy subject, and group 2 is type 2 diabetes without complication, and group 3 is type 2 diabetes with nephropathy. And in each group, we take 50 patients. These are the demographic and clinical parameters of the patients. We have choose age and sex matched on all 3 groups, and we find that in nephropathy groups, the blood pressure is very high. In diabetic nephropathy, this is significantly high compared to the control group, and the fasting blood glucose is also very high in diabetic nephropathy patients, and HbA1c is also high in diabetes and diabetic without complications. Serum creatinine is also significantly high in the diabetic patient with nephropathy. We determine the fructosamine level. This is an early glycated product, and it is also very much high in the nephropathy patients, and it is also high in diabetic patients without complication in comparison to the healthy control. And carbonate content is also high in diabetic patients, and thiol group is reduced in comparison to the healthy in diabetic nephropathy patients. So to detect the autoantibodies against Amadori-HSA, which we have produced in vitro, first we incubated HSA with various range of glucose in vitro, incubated at 37 degrees Celsius for 4 days, and Amadori product is confirmed by the NVT assay and authenticated by the HPLC using the furosine. Furosine is the standard of Amadori-HSA. We incubate HSA with different concentrations of glucose for 7 days, and we find a peak at 4th day that indicate that at 4th day the fructosamine level is very high in all the samples, and we take at 4th incubated sample the fructosamine content 107.2 in 75 millimolar glucose modified HSA. And with 50 millimolar glucose modified HSA, it was 75, and in 25 millimolar glucose modified HSA, it is 59.3. And in native HSA, it is very low, 6.6 nanomole per mg. So we took for the further study at 4th day incubated HSA with different concentration of glucose, and we detect the autoantibodies against it. For this, to detect the autoantibodies against Amadori-HSA in diabetes and diabetic with nephropathy patients, direct binding ELISA and inhibition ELISA has been done. The procedure the IgG was isolated from the sera of diabetic and diabetic CKD patients, which shows maximum inhibition with Amadori-HSA. To evaluate the interaction of patient IgG with Amadori-HSA, inhibition ELISA has been done. To evaluate the specificity of autoantibodies to Amadori-HSA in CKD patients, gel retardation assay has been performed. The microtiter plate were coated with respective antigens. 50 sera of the diabetic patients. These are the results from the diabetic patients without complications. We took 50 sera of diabetic patient without complication, or tested it for direct binding ELISA with native and different concentration of glucose modified HSA. Most of the sera showed highest binding with 75 millimolar glucose modified HSA, which is with respect to the other antigen. Out of the 50 sera, 32% sera shows highest binding with 75 millimolar glucose modified HSA, whereas normal healthy subject sera did not show appreciate binding with any of the antigen. In the case of diabetic nephropathy, 50 sera were tested for the direct binding ELISA to native and different concentration of glucose modified HSA. As seen, most of the sera shows highest binding with 75 millimolar glucose modified HSA with respect to the other antigen. Out of the 50 sera, 24 sera means 48% sera shows highest binding with 75 millimolar glucose modified HSA, whereas in this case normal healthy subject did not show any appreciate binding with any of the antigen. So the direct binding result, ELISA result shows that serum autoantibody shows appreciable highest binding to the Amadori-HSA is compared to the native analog in both diabetic group. 48% diabetic sera with nephropathy and 32% diabetic sera without nephropathy shows more binding with Amadori-HSA, that is modified with 75 millimolar glucose as compared to the native HSA. After that, we purify the IgG from the diabetic nephropathy or diabetic without complications patient sera, and IgG was isolated on the protein A gross column from the selected samples, which shows the highest binding with 75 millimolar glucose modified HSA in both group, and purified IgG evaluated as a symmetrical single peak on the affinity column. And in SDS page, it shows the single band that prove the purity of the isolated IgG. After the isolation of IgG, we competitive ELISA of IgG isolated from diabetic patient with or without nephropathy has been done to evaluate the specificity of the antigen to antibodies. IgG was isolated from 8 diabetic patients without nephropathy. These sera shows highest binding with in direct binding ELISA, and 16 sera with nephropathy patient that shows the maximum enhanced inhibition with an Amadori-HSA. The mean of the inhibition with Amadori-HSA as inhibitor was 57.17 without nephropathy and 75.04 with nephropathy, while the native HSA it was 30 in diabetic without nephropathy and 35.69 in diabetes with nephropathy. The maximum percent inhibition was caused in the activity of nephropathy antibodies, while antibodies from the diabetes without nephropathy were least inhibited. These are the results of inhibition ELISA, and we can see in this that the native HSA used as an inhibitor, the mean of 8 sera was 30.37, and the mean of 8 sera without diabetes without complication with Amadori-HSA it was 57.17. And in case of diabetic patient with sera, the percent inhibition is high. It was with Amadori-HSA, it was 75.04 with Amadori-HSA and 35.69 with native HSA. These results shows that the specificity of antigen against Amadori-HSA is very prominent in the diabetic nephropathy patients in comparison to the diabetic patient without complication. To prove this interaction, the true interaction has been visualized by the gel retardation assay. For this, the interaction of native and Amadori-HSA with the IgG purified from diabetic patient with nephropathy, we perform the gel retardation assay, and the result shows that the purified IgG from diabetic patient with nephropathy was strongly bound with Amadori-HSA but not with the native HSA. This figure shows the interaction between IgG purified from nephropathy patients and Amadori-HSA. First, we isolated the IgG from the nephropathy patient and incubate this with Amadori-HSA and the gel retardation assay has been performed, and we can see this. We can see in this figure that the progressive retardation has been the progressive retardation in the electrophoretic mobility and the corresponding decreased band intensity we found that suggests the isolated IgG from the nephropathic patient has strongly bound to the Amadori-HSA. However, in native HSA, HSA did not show any visible retardation in electrophoretic mobility. So the conclusion of my study is that, due to the neoepitope generation, self-protein becomes immunogenic and may induce autoantibodies in the diabetic patients with or without nephropathy. Serum autoantibodies in type 2 diabetes patients with nephropathy shows preference for the Amadori-HSA, indicating a causal role of this in the pathogenesis of diabetic secondary complications. The systemic rise in the level of autoantibodies against Amadori-HSA could emerge as additional authentic biomarker for the assessing secondary complications in diabetic patients with or without complications. Hence, inhibition of Amadori-HSA may be the target for reduced or delayed to diabetic vascular complication progression. Thank you.
Thank you for your presentation. Any comments or questions for the speaker, please?
Very nice presentation. I think the future will be to identify the early lesions and early biomarkers and to interfere. And also, as raised point yesterday, to look at a variety of glycosylated proteins and look at the functional or non-functional aspects of that glycation. I have a question for you from the chemistry point of view. Do fructose and sucrose react with albumin or proteins? We are talking about glucose.
Yeah.
How about the fructose from fruits and sucrose? Do they also react?
Yeah, they are also involved in the non-enzymatic glycation reaction, but glucose is...
Use microphone.
Glucose is present in very high amount in our body, so we choose glucose.
I agree. The reason I'm asking is, in the diabetes management, a lot of people say eat a lot of fruits. But no study has been done the effect of eating a lot of fruits on whether or not.
Studies have been done. Fructose is also a good glycating agent.
Yeah, but yeah,
not the sucrose, because sucrose lacks the carbonyl group. Because carbonyl group is bound, it is a non-reducing.
I know, but just I want to very clarify.
Yeah.
Has anybody done studies to look at hemoglobin A1C after consuming a lot of fruits?
That I don't know.
Yeah. Okay.
Yeah, but the fructose is a glycating agent.
Okay.
Fast glycating.
Okay. Thank you.
Any additional questions or observations? Comments? Okay, thank you, Neelofar, for your contribution. This is your